Hi again everyone, welcome back. I want to talk about exact trig values. It just so happens with angles that there are special numbers. Now everyone knows when they're doing angles we're talking about 90 degrees being a right angle and 180 degrees being a straight line and 360 degrees being circle or revolution. If we halve the 90 we get 45, and if we get a third of the 90 we get 30. And for some reason those ones happen to be really nice when it comes to trigonometry. Let's have a look at what happens with those ones, and that's what we're going to talk about. If I started with a right angle triangle that had an angle of 45, what does it tell us about the triangle? It instantly says that this other angle here also has to be 45 degrees. Then it also says to us that it's an isosceles triangle. That means the length of this side has to equal the length of that side. And to make life easier, we could make them both 2, make them both 3. We could go 10 and 10 or 50 and 50. But to make life easier, let's just make them 1 and 1. So if that was 1 metre and 1 metre, we could figure out how long that one is. Go back to Pythagoras. I like to write h squared equals a squared plus b squared. I prefer to write h for hypotenuse. Depending on your school, a lot of people will write c squared equals a squared plus b squared. But I tend to write h, but if it mucks you up, you can go through it that way. So if I put an x for the hypotenuse, and x just means I'm finding out how long the hypotenuse is. So that x replaces the h, which is substitution. The 1 replaces the a, and by the way, it doesn't matter whether it's that one or that one, it makes no difference. The 1 replaces the b, and I've got x squared equals 1 plus 1 is 2, and I've got x as the square root of 2. So if we go back to the triangle, this is now square root of 2. So starting here at this 45, I could have started at the other 45, wouldn't make any difference. This is the really obvious one. Some kids really struggle still with doing trigonometry. They don't usually struggle with the hypotenuse, they struggle with the opposite and the adjacent. Interesting, if I go to this 45, adjacent just means next to. So adjacent is just simply next to. So I could talk to you about who sits adjacent to you at school. You might have someone on your left and you might have someone on your right. I should say it the other way from your point of view. Someone on each side of you. Sometimes you might only have one person sitting next to you and they're the person that's adjacent to you. It just means next to you. Let's have a look to it. So the one that's next to the 45, that's not the hypotenuse, that's next to the 45, but it's already called the hypotenuse. So this one here is called the adjacent. I'll leave one side left that's not next to the 45, it's actually opposite the 45. So refer to that as the opposite. So we're going through basic trig again, but still, let's just go through what that is. So there's the opposite, there's the hypotenuse, and there's the adjacent. If I wanted to get the tan of 45, most people are okay at this stage, that's the opposite divided by the adjacent. So that would be 1 over 1, which is just 1. So go back to the special ones, we're just talking about 45 degrees, and the tan of 45 degrees happens to be 1, which is rather nice. And if I go to the sine of 45 degrees, which is the opposite over the hypotenuse, and we could write that up, so we're talking about sine, which uses the opposite and the hypotenuse, so we've got the opposite and the hypotenuse of 1 over root 2. Not as nice as 1, but still for mathematicians and a lot of math calculations it's really nice. And then we can go to the cos of 45, and it's the adjacent. So cos is adjacent over the hypotenuse. So there's the adjacent, so that's 1 over root 2. Rather interesting that they're the same answer, but it's an isosceles triangle, so it has to be. Then we have a problem. What happens when it's 30 degrees and then as well as 30, what if it's 60? So there's one thing we can do. We can draw up a equilateral triangle, so that's 60 and that's 60. If I split it down the middle, splits that 60 in half, that's 30 and that's 30. Now we want to use ones as much as possible. If we use 1 there and 1 there, this will become half and half, because if you split it in the middle it's equal inside. So if I put a 1 there and a 1 there, that makes all the way across a 2. Equilateral triangle means that will be a 2 and that will be a 2. This triangle is used to memorise when it's 30 and also when it's 60. Let's have a look at this triangle here though. I'm going to draw it separate because it does muck people's brains up. I had that one there. There's the 60, there's the 30, there's the 1, there's the 2, and again I'm going to use Pythagoras. I'm going to try to keep the one board so I'll keep it together. So hypotenuse is 2 squared. So back to h squared. Now we want a squared. I usually write the x first to keep it the same, and that's a 1 squared. Now I've then got the 4 equals x squared plus 1. So if I subtract 1 from this side, I subtract 1 from that side, and I'm left with x squared equals 3. So x equals the square root of 3. Don't forget, if you're getting rid of a squared, you get a square root. Because you actually take the square root of the left hand side, you take the square root of the right hand side, because square and square root, like they cancel each other out, they're actually the opposites of each other. So now we can go back to this triangle and say that's not an x, it's now actually a root 3. Back to the basics on Pythagoras. There's your right angle. So if we started, say, at 30 degrees, no doubt in people's mind, usually there's the hypotenuse, there's the one right next to it, so that can't be the opposite because it's next to it, and across here is the opposite. Now we go through the others. Sine 30 will be the opposite over the hypotenuse, so sine's opposite on hypotenuse, so that's a 1 on 2. So what would cos 30 be? That was nice to be a half. Over here we had a 1, now we had a half. Cos 30 is the adjacent on the hypotenuse, so that's the adjacent root 3 on 2. You go, that's not bad. Root 3 is a bit annoying. I know it's 1.732, but you know, it's not bad. Now I can go to tan of 30. So tan is opposite on adjacent, so we're starting at 30. Opposite on the adjacent is 1 on root 3. So it's always a problem, everyone's got to memorise these or get used to them. First thing I used to do whenever an assessment started, I'd just quickly scribble my 2 triangles up, and instead of memorising, I knew them from them. But after a while you get the hang of it. Let's now go for the sine of 60. So sine is opposite on hypotenuse. So now instead of starting at 30, we are starting at 60. And I'm going to go to the opposite on the hypotenuse, which is root 3 on 2. And again, out of interest, it just happens to be the same as that one. So we go next one, we've got the cos of 60, which happens to be the adjacent on the hypotenuse. So you've got the 1 on the 2, the adjacent, starting 60, the adjacent on hypotenuse, 1 on 2. So that's a nice one again. Half's nicer than root 3 on 2. And then you've got the tan of 60. So that's what, tan starting at 60, instead of now being called the adjacent. I should have got rid of them a moment ago. This will be now the adjacent, and that's the opposite. So the tan on 60 is the opposite on the adjacent, which is root 3 on 1. So go back in principle. When we split 90 up into a half and into a third, you get these numbers which are 30, 60, and then in half, of course, it's 45. And it gives you 9 nice ones that we can use all the time to get some nice calculations without having to pick up your calculator. And that's exact trig values. Thank you.